Have you ever looked up at the night sky and wondered about the origins of the stars? How did they form, and what makes them distinct from each other? In this video, we will take a deep dive into the classification of stars into population I, II, and III, and what makes them unique. Population I stars are made up of younger stars, clusters, and associations that are believed to have formed between 1 million and 1 billion years ago. These stars are often hot blue-white O and B type stars, and are called extreme population I objects. They are found near the arms of galaxies such as the Milky Way, and other spirals, as well as irregular galaxies like the Magellanic Clouds. On the other hand, population II stars are made mostly of hydrogen and helium gas, and are generally found in the halos or globular clusters of galaxies. They are much older than population I stars, and are generally less abundant and dimmer. These stars tend to have lower metallicities and thus contain fewer heavy elements. And then, there are the population III stars. These are the very first stars to have formed in the universe, composed of primordial gas left over from the Big Bang. If they exist, they are characterized by interesting features, such as being composed entirely of hydrogen and helium gas, with no metals or elements. If we could find a population III star, its spectrum would be basically flat except for the hydrogen and helium lines. But what makes population III stars so interesting is that they have never been observed before. Despite their importance in the early universe, astronomers have never been able to find a population III star. This is partly due to their elusive nature and the fact that they are believed to have exploded into supernovae shortly after their formation. However, recent discoveries by the James Webb Space Telescope may have changed this. In December 2022, scientists analyzed approximately 2,000 different targets within JWST images, looking for specific helium emissions that are expected to be found in population III stars. They discovered a galaxy with a redshift of 8.16 that appeared only 620 million years after the Big Bang. This galaxy appeared to be split into two parts, with one half possessing helium signatures as well as many other elemental signatures. At first, it was assumed that the population III stars in the galaxy had already created a lot of younger stars and caused the production of other emissions. However, the intensity of the helium emissions implied that this may be a region rich in population III stars. The emissions did not include oxygen, nitrogen, or carbon signatures, which excludes the presence of a black hole. Therefore, this is quite an intriguing discovery. James Webb might have found a region in the universe rich in population III stars. This discovery has opened up a wealth of possibilities as to the origin of the emissions from the galaxy. It will be interesting to see what further studies uncover, and to learn more about this unique discovery. Unfortunately, this discovery doesn't really tell us anything about the existence of population III stars, because what we see is a mixture of multiple emission lines. It could be that this galaxy is made up of population III stars and other types of objects, but there's no way to split the components to verify this hypothesis. What scientists are hoping to find is the light of the population III stars. That gets magnified by an effect known as gravitational lensing. This is a relativistic effect that takes into consideration the fact that light gets bent when it gets close to a massive object. For example, the light from a population III star could get bent, and therefore magnified, just like it happens with a lens, by a massive cluster of galaxies that lies between us and the population III star. A bunch of stars has already been discovered with this method, but it is quite a rare event because of the geometry of the problem. You would need the lens, for instance, a cluster, to be aligned with the emitter, in our case, the population III star. And you also need to be lucky enough to observe that specific region of the sky when this happens. So, what can we say? Based on the current evidence, it appears that population III stars are likely to remain elusive in the future, while the possibility of finding some population III stars in the distant universe can't be completely ruled out. The probability of this happening is still very low. Continued observations and research will be required to further advance our understanding of the formation and evolution of these mysterious stars, thereby providing insight into the early history of our universe. But why are population III stars so important? Well, These stars are thought to have played a critical role in the formation of the first galaxies and in the enrichment of the universe with heavy elements. We would also be able to study the primordial gas from which the star was formed, providing insights into the conditions present in the universe just after the Big Bang. In addition, studying population 3 stars could shed light on the processes by which heavy elements, such as carbon and oxygen, were formed in the universe. These elements are crucial for life as we know it, and understanding their origins could have profound implications for our understanding of the universe and our place within it. Of course, there is still much work to be done in the field of astronomy, and new discoveries are being made all the time. One thing is for sure: the study of stars, galaxies, and the universe as a whole is an endlessly fascinating pursuit that will continue to captivate and inspire us for generations to come. So, what can we do to support this incredible field of research? There are many ways to get involved, from supporting space exploration programs to donating to organizations that fund scientific research. We can also encourage our elected officials to prioritize funding for scientific research and to support policies that promote scientific discovery and exploration. In the end, our understanding of the universe is only as good as the tools and resources we have at our disposal. By working together and investing in scientific research, we can unlock the mysteries of the universe and gain a deeper understanding of the world around us. If you enjoyed this episode, make sure to like, subscribe to our channel, and press the bell icon so that you don't miss any future episodes of the Orbital Insights. Thank you for watching, and until next time, keep exploring and be curious about space.